Yeah, this week lesson's going to be on polymers, okay? So what you're going to be learning, you're going to be learning what a polymer actually is and what it's built from. You're going to be learning how to name and draw monomers, polymers, and also repeating units. So depending on if you're going through this by PowerPoint or if you're watching a video, but if you're watching a video, hit pause so you can do this after. You're going to have to look back at your Unit 2 notes and draw the structural form for ethene, what the functional group of ethene is called, and another word just describes a group of compounds. So at the National 5 level, the only polymers we'll be looking at are called addition polymers, and they're formed from addition reactions. Just have a little think about where you've seen addition reactions before. There's a twig video also attached here, so make sure you watch it, and it's about 3 minutes long.
From toothbrushes to telephones, straws to spaceships, plastics are used in an enormous range of products, and have been for the last 150 years. Though they can have very different properties, they're all synthetic materials called polymers, made in a similar way. The building blocks of polymers are small molecules called monomers, obtained from crude oil. The carbon atoms are joined by double bonds, but these can be broken to create single bonds, free to join other carbon atoms and form long chains called polymer molecules. This process is called polymerization, and the resulting polymers are the main components of plastics. Plastics often take their name from their component monomers. So ethene becomes polyethene or polythene. Similarly, styrene becomes polystyrene, and propene becomes polypropene. The reason plastics have different properties isn't just because they're made from different monomers. It's also down to how their polymer chains are arranged and held together. Take high-density polythene, for example, with straight polythene chains packed closely together, producing a high-density material. It's rigid, strong, and used to make plastic milk bottles. But branched polymers cannot pack so easily, so the density is low. And this lighter, flexible material makes plastic bags. The force of attraction between polymer molecules also has an effect. The stronger these intermolecular forces, the tougher the plastic is, and the higher its melting point. Polymer properties can be changed by adding certain ingredients. Cross-linking agents create strong covalent bonds between adjacent polymer chains, making the material stiffer, stronger, and more heat-resistant. Plasticizers, on the other hand, make the material bendier by getting in between the chains and weakening the forces of attraction between them.
So as you've seen from the twig video, polymers is actually another name for a plastic. Okay, so if you want to make a plastic, you need to add what is monomers together. Okay, mono we've seen in chemistry before, and it stands for one, and the mer stands for part. So a monomer is just one part, a single part. Poly is a word for many. A polymer is many single parts joined together, so many parts all joined together. It's called polymerization. So when many monomers join together to form a polymer, what you get is these long chain molecules, and they contain a repeating unit, which we'll look at repeating units in a little bit here, a few slides. But you can see in this long chain molecule, it's left open at both ends. Because what we're showing here is just a section of a long chain molecule. This could be thousands and thousands of monomers added together. Okay. The bottom one here, polystyrene, you can see here, this section here is just been repeated. So this is the repeating unit. So it's been repeated many, many times. So I want you to write down these definitions. You must know them, so you must learn them, so you must get them into that brain yours. So polymers are just long chain molecules formed together by a large number of monomers. A monomer is a single unit molecule from which a polymer molecule is built up from, and polymerization is the process from which the monomers join together to produce your polymer. So we're going to run over a few examples. We've got ethene. Now, ethene is a small monomer. This is going to be added together. You can see it's an addition reaction because the double bond is going to open up and they're all going to add together. The ethene itself is unsaturated because it's got the double bond. Once the double bonds open up and they all join on together, the actual polymer, which is polyethene, is saturated. So although the name of the polymer, you just put poly in front of the name of the monomer, so it's still got an ene there, but it's actually saturated. So you can see here we've got 3 monomers, 1, 2, 3, joined together to form your long chain polymer. Right, so try not cheat on this slide. Have a wee go at it yourself before you flick on and get the answer. So we've got PVC as a monomer, and it comes from vinyl chloride. You can see here, this is your vinyl chloride here. This one here is obviously just your monomer diagram. Okay, so it's this one here you're going to be drawing out. So it says draw 3 monomers side by side and then draw the polymer section that would be formed. You can look back 2 slides at slide 8 for help, because it's similar diagram done there. So we want 3 monomers side by side and then draw the polymer section that would be formed. Hopefully you've had a little go at doing it yourself, but here you go, you've got your 3 monomers sitting side by side. The double bonds will open up and these 3 monomers will add on to each other. The polymer unit itself, 6 carbons in it. You can see here that the chlorine is going to be on every second carbon. And then for the repeating unit itself, this has been repeated. So that was how you draw the repeating unit. Now you can notice the repeating unit is the same as the monomer. The only difference is they don't have a double bond here. Okay, because we've got no double bond in your polymer unit. So we've got no double bond in the repeating unit. Put a little square bracket around it, and then we put an N on the bottom right hand side. And this is because this repeating unit is repeated any number of times. Right, so here we've got another one that you can have a wee go on your own. So try it first before you look at the answers. If you're watching a video, just pause it. So we've got an unsaturated monomer called acrylonitrile here. So you can see double bonds in the middle. What you have to do is you have to draw the polymer section. Okay, when we say polymer section and polymers, we mean 3 monomer units joined together. Okay, so draw the polymer showing 3 monomer units joined together. I want you to see if you can name the polymer from its monomer name and to draw the repeating unit. Remember, the repeating unit is similar to the monomer, but it doesn't have the double bond. So here we've got here your polymer section. So you can see here we've got 1, 2, 3 monomer units joined together. Acrylonitrile, so it's polyacrylonitrile. And the repeating unit is what's been repeated. So one here has been repeated. And it's been repeated any number of times. Another thing to remember is when you do the polymer section, don't close it off at the end. Okay, leave this bond here open or you'll lose a mark in the exam. Because we're just showing a small section of the polymer, so this isn't completed. And likewise, when you're doing the repeating unit, leave the bond open at the end. It's another one for you to try, but this time the answers aren't on the next slides. So I want you to hand your answers into your teacher so that they can check your knowledge of this topic. So this time you're given the polymer section and you're asked how many monomer molecules have been joined, draw the repeating unit and draw the monomer. Right, so here we've got is butene. Now butene is quite complex in the sense that there's 4 carbons here. So for this double bond to open up and for more butene monomers to add on together, it's quite difficult because you can see here this is in the way and this is in the way here. Now what you need to be able to do is you need to be able to draw this, what is an H shape, so you can visualise them joining together. So here's 2 examples here. Now both mean the exact same. So remember we said that the bonds can rotate, they can flex about. So this methyl branch here can move up here. And likewise this methyl branch here can occupy this space down here. So drawn it in an H shape, drawn it like this. The exact same. It's still 1, 2, 3, 4 carbons in a row. 1, 2, 3, 4 carbons in a row. And drawn it this way, it allows you to visualise the next monomer side, being able to join onto it. And here we go here, and this is going to be a final product then. We've got 3 butene monomers added together. So your first one starting here, 1, 2, 3, 4 carbons in a row, your double bonds opened up. 1, 2, 3, 4. Double bonds opened up. 1, 2, 3, 4. 4 butene monomers joined together.